So now today's lecture we are going to discuss about the crystal bonding. So now since in the previous chapters we have learned about the crystals. So in the crystals the atoms are arranged in a particular geometrical fashion. So and it has particular symmetry. Suppose it has 4-fold symmetry, 5-fold symmetry, 6-fold symmetry and 1-fold symmetry, and these atoms are fixed in their positions. So now there is a obvious question arises that that how these atoms stay together to form a crystal. So now in this chapter we will discuss how these atoms stay together to form a crystal and become stable. So now these atoms are held together by some type of binding, or you can say there is some kind of a bonding between the crystals, atomic crystals, and you can say there are some kind of forces which tend to fix these atoms or tend to make these atoms together. So these forces, you can say these forces are known as cohesive forces, and these cohesive forces can be in electrostatic force, or these can be your electrical in nature, because you have atoms and atoms have proton and neutron, and when you have two atoms they are approaching to each other, there will be electrostatic attraction between proton and electron of other atom, and repulsion between electron and electron of particular atoms. So these so then we are going to discuss about this cohesiveness nature of these forces. So now let us discuss how these forces acts in the atoms of crystals, and what is their nature and how they vary with their distance. So now let us consider two atoms in their ground state, means they are stable and they are infinitely far away from each other so that they cannot interact with each other. So now when these two atoms are at infinity, so their potential energy is also equal to 0. So now as the distance between them increases or decreases, so thus your potential energy will also vary, and it will be generally inversely proportional to some power of distance of separation between them. So now since these atoms carry your protons and electrons, positive and negative charges, so thus when they approach each other, these two atoms approach each other, they may attract or repel to each other. So thus potential energy total potential energy will be the sum of the potential energy due to attraction and potential energy due to your repulsion. So now your potential energy, your you can say attractive potential energy is equal to minus some kind of constant divided by your distance between them and some power n, and your repulsive will be some constant beta and inversely proportional to the distance and some power m. So positive here, attractive is negative, a sign is there because potential energy decreases in case of attraction, and potential energy here is positive. So in negative sign you can also infer from you have studied your electricity and magnetism. So when you place two charges, and uh, when you take one charges to the near to the your that particular source charge, so distance decreases and the force is against your electrostatic field, and distance also decreases, so therefore work done is negative. So since work done stored is as a potential energy, so therefore potential energy is equal to 0. So potential energy also negative. So thus the positive and negative sign is came from here, that work done. So So then what will be the total potential energy? Total potential energy will be the sum of U reactive and U repulsive. So now the total potential energy will be, because this is the function of R, because this is varying as distance between two atoms, and here alpha and beta are a constant of attraction and repulsion, and M and R are the your characteristics of particular molecule. So now this will be minus alpha Rn plus beta divided by R raised to power M. Question number 3. So now thus the forces between these two atoms will be, then force between these two atoms will be, this is also function of R. This will be, since we know that the force is negative of gradient of potential energy. This all we know, that force is negative of gradient of potential energy, because since we know that your potential energy is F into dr, this is work done, F into dr negative, so therefore the force is negative of gradient of potential energy. So therefore this will be putting the minus d on dr minus alpha Rn plus beta Rm. So now when you differentiate with respect to R, so this will be इसको अलग से करेंगे, so this will be minus plus, and when you differentiate, alpha will be here, differentiate this quantity, and R is to power minus n, so minus sign will be there, and n also will be there, and this will be minus R minus 1. So when you take this will be R n plus 1, this will be R n plus 1, and this will be minus, and minus will be come from this factor, this will be plus, this will be beta m divided by R m plus 1. You should know that why this come, एक को मैं करके दिखा देता हूँ. This will be minus alpha will be there, this will be R minus n. When this is differentiated, this d upon dr, इसको ऐसे लिखते हैं, so this will be minus n alpha R n minus 1, this will be minus n alpha, so this will be R minus n plus 1 bracket में, so इसको नीचे लेंगे, this will be minus n alpha R n plus 1. So this how this has come. So similarly this will be there, so this will be F R. So since you can also, according to book, you can arrange plus 1 plus m beta R m plus 1. This is equation number 4. So this is the forces between these two atoms. So now, so the system of two atoms will be stable at particular separation. So now this system of two will be stable at a particular separation, that is R is equal to R naught, and this condition is corresponding to minimum energy. This condition is corresponding to minimum energy U R naught. So minimum energy क्यों लेते हैं बेसिकली फिजिक्स में, ये minimum condition क्यों लेते हैं, because every system or every body or every particle in this universe, it tends to occupy the minimum energy state, because at minimum energy state the system or a particular body or particle becomes stable. So now since we know that our universe is originated from Big Bang, so at the Big Bang energy was infinite and energy density was infinite. So now the universe is, we know that from practical satellite experiments, your universe is expanding. So universe will tend to expand when their energy becomes minimum, or it tends to occupy your thermodynamical equilibrium, or you can say there is heat death of the universe. So every particle or every system in this universe is tending to occupy your minimum energy state. So therefore we are taking a minimum energy condition here. So at minimum energy condition your system becomes stable. So this it can also, you can say that this is also, you can say that in other words, this is binding energy, a minimum energy, or you can say that this is binding energy. And the binding energy in terms of minimum energy can be written as binding energy will be negative of this your minimum energy, and this energy is required to pull the crystal apart into set of free atoms. सो बाइंडिंग एनर्जी आपने केमिस्ट्री में पढ़ी होगी कि किसी बैलेंस इलेक्ट्रॉन को आपने बैलेंस सेल से निकालना हो, दैट मिनिमम एनर्जी रिक्वायर्ड टू ब्रेक दैट break apart that balance cell from that its orbit. So that energy is known as binding energy. So in this case your crystal, when you, because the atoms are held together in crystals, so when you tend to your pull these crystal apart into set of free atoms, you can say you can ionize particular system. So therefore this will be the energy, this will be the negative of that minimum energy, and it is also known as your dissociation energy, and it is of the order of electron volt. So now when your, because at minimum energy condition R is equal to R naught, so then du upon dr is equal to 0, which means मैथमेटिकली हम मैक्सिमम योर मिनिमा और मैक्सिमा को कैसे रिप्रेजेंट करते हैं, स्लोप को 0 कर देंगे, बिकॉज एट, अगर तुम आप ग्राफ भी बनाएंगे तो ये मैक्सिमा है तुम्हारा और ये मिनिमा, या मैक्सिमा और मिनिमा यहाँ होगा. एट मैक्सिमा एंड मिनिमा योर स्लोप इज ऑलवेज इक्वल टू 0. So therefore at minimum condition your slope is equal to, because this represents gradient or slope, so slope will be equal to 0. So at minimum energy your du upon dr is equal to 0. So now put this du and is equal to dur is equal to 0. So thus this for this minima du is equal, du upon dr is equal to 0. So since this is the value of the gradient of your potential energy, so thus you can rearrange this, you can solve this. So this n alpha r n plus 1, इसको इस तरफ ले जाएंगे, this will be minus m beta divided by r m plus 1. So minus sign will be cancelled. So now you can rearrange mathematically. So n plus 1, so if you cross multiply, this will be r m plus 1, this will be here, this will be r n plus 1, and this will be m beta divided by n alpha. So now if you rearrange this, keep this will be r m plus 1, इसको ऊपर ले जाएंगे तो आएगा r minus n, ब्रैकेट में होगा तो क्या आ जाएगा, ब्रैकेट हटा देंगे तो हो जाएगा -1. So this will be m beta upon n alpha. So this will be r m plus 1 minus n minus 1. So this will be 1 will be cancelled. So this will be r m plus 1 minus n alpha. So this will be 1 will be cancelled. So this will be r m plus 1 minus n alpha. So this will be 1 will be cancelled. So this will be r m plus 1 minus n alpha. So this will be 1 will be cancelled. So this will be r m plus 1 minus n alpha. So this will be 1 will be cancelled. 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 So this will be 1 will sorry, this, because this is at minimum condition, r is equal to r naught, because this was the condition. At r is equal to r naught, your du slope, your gradient is equal to 0, du upon dr is equal to 0. So this will be r naught, this will be r naught. So r naught m minus n, this will be m beta upon n alpha. This is equation number, your equation number 5. So now you can, so thus equation number 3 at r is equal to r naught becomes, so u r naught is equal to minus alpha r raised to power n plus beta r naught raised to power m, where alpha and beta are the constant of attraction and repulsion respectively. So thus now we can rearrange this, put this minus alpha r naught common, this will be 1, and this will be minus beta upon alpha, and this will be r naught n, this will be r naught m. This we can rearrange. So now this will be alpha r naught raised to power m 1 minus beta upon alpha, since you can इसको नीचे लेंगे तो एक r raised to power minus n, this will be r naught m minus n, this will be u r naught. So now by putting the value of your equation 5, this value into this equation, so now by using equation 5 we get your u r naught equal to minus alpha r n 1 minus beta upon alpha, your this will be reciprocal होगा, तो this will be your m beta into n alpha. So alpha cancel, beta cancel, so this will be minus alpha r raised to power n 1 minus your n upon m. This is equation number 6. So now since this is the condition for stability, so now, or you can say that this is the equation for the condition for equilibrium. So now at equilibrium the forces, attractive and repulsive forces, becomes equal, because this is the condition for force. So the forces becomes equal, but your repulsive and attractive and repulsive energies are not equal to 0, because your n and m are not equal to n and m are not equal. So thus from this equation number 6, that when m is greater than n, that means whole energy is attractive in nature. So and this can be determined by the following process. So now we will take the your gradient of dr. So now I will take the double integration of u with respect to r, this will be greater than 0. Condition for maximum and minimum, this will be d raised to power u d raised to power d square u upon dr square is equal greater than equal to 0, and for which condition किसके लिए होगी, r is equal to r naught. So now since I have the value of du upon dr which is equal to since this is equal to equation 4, now I will differentiate equation 4 with respect to dr. So this will be, so now differentiate this with respect to dr, so this will be at r is equal to r naught, so this will be your इसको डिफ्रेंशिएट करेंगे तो हो जाएगा n अल्फा तो पहले से ही कांस्टेंट है, सो इसको ऊपर ले जाएंगे तो हो जाएगा माइनस, दिस विल माइनस n माइनस 1 ऊपर चला जाएगा, तो डिफ्रेंशिएट करेंगे दिस विल बी n to this will be n plus 1, minus sign will be there, and divided by the same procedure which I have told, this will be r n plus 2, and this will be same, minus minus plus, this will be m beta m plus 1 r m plus 2 at r is equal to r naught greater than 0. अब r को r naught पुट कर देंगे, so this will become n your n plus 1 into alpha divided by r naught n plus 2 plus m plus 1 beta divided by r naught m plus 2 greater than 0. So now इसको इस तरफ ले जाएंगे तो हो जाएगा प्लस, दिस विल बी m plus 1 beta r naught m plus 2 greater than n plus 1 alpha divided by r naught n plus 2. So now rearrange this mathematically, this will be इसको इस तरफ ले जाएंगे, इसको इस तरफ ले आएंगे, this will be n m plus 1 beta divided by n plus 1 alpha, this will be r m plus divided by r naught n plus 2. इसको ऊपर ले जाएंगे तो ये जाएगा r naught minus n minus 2, so minus 2 plus 2 minus 2 will be cancelled, this will be r minus m. और मैं इसको करके बता देता हूँ, this will be r plus 2 minus n minus 2, this 2 minus 2 will be cancelled. So now since we have calculated this value r naught m minus 1, so this is we have calculated from equation 5. So now we have from equation 5 we have m plus 1 beta n plus 1 alpha greater than, so this the value of r naught m minus 1 is equal to m beta divided by n alpha. So now what you have left, that is your Mm, this will be cancelled, beta will be cancelled, alpha cancel, mn cancel, so this will be so since from this m plus 1 is greater than n plus 1, or you can say that m is greater than n. So now for this condition, when m is greater than n, so thus your that attractive repulsive term becomes small, so thus in this case your attractive terms dominates. So for this condition your attractive terms dominates.